Welcome to this training resource on inspection and certification of timber and timber products that are used in house construction. Basically what we're looking at is equipping you with the information that you need to be able to certify timber products properly, to be able to look at how they're going in installation and then inspect them at the end to work out whether or not they comply. And basically our scope, we're looking at timber in housing, we're looking at new houses, new timber in new houses, and we're looking at both stick-built houses and prefabricated construction. Ultimately, we're looking at a range of timber products, but the important thing is we're looking at compliance. Does the timber comply? Does it comply in the setting at the end? These are the modules that are part of this training package. The first one looks at codes and standards. That is the bar that we've got to jump over, and then it works through a number of different issues right down to the final inspection where we're looking at how is the timber in the final building. Module number 1 is Australian standards. When we say timber complies, it complies with the National Construction Code, and the National Construction Code is the document that puts together acceptable construction and design manuals, and these are the compliance documents that we're using. So they're primary reference documents in the BCA. They include product standards, they include design standards, they include installation and construction standards, and then trusses have a suite of standards that they look at themselves. So for timber design and construction, AS 1684 is our Bible. And there are 2 volumes that we mainly use. Volume 2 is for non-cyclonic areas. Volume 3 is for the cyclonic areas. And so if you're in an area that is experiencing cyclonic winds, wind region C and D, then we need to use part 3. There are 2 other standards that I've got on the screen, and these are standards that are used to support the AS 1684. So AS 1684 is an acceptable construction manual. It contains design information. It contains construction information. It contains span tables that designers use to select their members. It contains details for tie down and instructions and charts that assist with bracing. It has geometric limitations, and these are serious. We have just come back from looking at cyclone damage in North Queensland and some large buildings that used details for AS 1684 suffered damage. If the building is bigger than these limitations, then the loads are going to be higher and the details in AS 1684 may not apply. So we're looking at 2 stories. So we're also looking at the distance across the width of the building perpendicular to ridge no more than 16 metres, maximum internal wall height per storey at the eaves of 3 metres, roof pitch 35 degrees, and a raft of different roof types. So that they are serious limitations. If your building exceeds those limitations, if your house exceeds those limitations, AS NZS 1170 Part 2 is used for the wind loads, and AS 1720 Part 1 is used for the timber design. Timber trusses, there are 3 standards that are important in timber truss work: a design standard, a manufacture standard, and an installation standard. And each of these will become part of the documentation for timber trusses. The timber truss design standard is relatively recent, and it contains all of the design criteria that are used for trusses. These design criteria are acceptable and compatible with AS 1720 Part 1, the primary timber design standard, but they give a uniform footing across the entire truss industry. Now, trusses are designed by software. There is nobody with a slide rule or a calculator punching out designs. It all happens automatically. And so that software has been designed and certified as compliant with the design standard. Structural timber products. So that there are lots of structural timber products, there are lots of different structural product standards. The most important one of these is AS NZS 1748, which is the grading standard, the product standard for MGP material. And probably 90% of structural material in homes is going to be an MGP grade. Then there are visually graded standards They've been in Australia for a long, long time. 2082 and AS2858 are visually graded standards. And then there's LVL, glulam and plywood. Each of these products have their own standard. Each of them produces a structural product. And a structural product has properties. And those properties are called cumulatively, all of the properties together are called a stress grade. So that those properties relate to the designation of the material. The stress grade properties are presented in AS 1720, but they're also linked to the span charts in AS 1684. So that the end result of the production of a piece of timber is a grade mark. And there's a shot of a number of different grade marks. And those grade marks are the link between a piece of timber and what that piece of timber can do structurally. And so there's some grade marks. This one's got a grade mark on the edge. Sometimes they're a bit hard to read, but they all give a link to the potential performance of those pieces of timber. And finally, in this module, non-conformance and non-compliance. So that there is a difference between non-conformance and non-compliance. Non-conformance means it doesn't comply with its own specification. So every product has a specification. If it doesn't comply with that specification, it's non-conforming. And compliance means, does it comply with the NCC and all of the primary reference documents in the NCC? So that a non-compliant product or a non-compliant use of a product means that it's used in such a way that it doesn't actually comply with the NCC. Now, products can be both non-conforming and non-complying, but our aim collectively is to ensure that everything is both conforming with its specification and complying with its Australian standards.